Hey guys, Matt here. So in this set of videos, we're going to be taking a look at some machining methods. And in this first video, we'll be also focusing just on lathes. Okay, so first thing we're going to look at here is a setup of a lathe. So we've just got a diagram here showing a basic sort of lathe. This is where the workpiece that we're working on will rotate, and it can obviously rotate at different speeds depending on how we adjust it. So the bigger the piece, so the larger the radius we're dealing with, the slower we'll rotate, because at the surface of that material, obviously a bigger material will rotate at a faster speed than a smaller one. Here is where we attach our sharp tools for what we're cutting and how we're cutting. And it's attached to this carriage, which can slide up and down here depending on where the work piece is and what sort of feature we're trying to add to that workpiece. It can also slide in and out at right angles, also once again depending on what we're trying to achieve with our lathe. And we can also tilt it at angles to get other certain features, so maybe sort of chamfers and that sort of thing. At the end here we have a tailstock. This slides in and out axially using these handles here, and generally that is in line with the center of our spindle. If need be though, it can be moved off center, however that's generally uncommon. Down here we also have a geared lead screw on a spindle, and we can set this so that it moves along at a particular, so our carriage moves along at a particular rate compared to our spindle speed, so we can control what sort of cut is being made gradually along our workpiece. Okay, so now let's take a look at some of the turning operations. So we've got a sort of long workpiece here just with a few different operations going on, and we've got it being held at this side here, which would have been our tailstock in the last slide there. And just a note, we generally use that tailstock if we're dealing, say, with long, slender, not so rigid pieces, to keep them rigid and straight. So the first thing we're going to look at here is this tool here, the right hand turning tool to start off with, and we've got an image here. So as you can see in here, it's rotating on our spindle in the left hand side here. It's not being held at the end for this operation, and it looks like we've got a roughly square tool, but it's only just touching at this left hand edge, and that's moving along here to make this machine surface with this slight little round in the corner there. And generally we're taking off just fractions of a millimeter at a time, or with bigger lathes we can take off up to a couple of millimeters. So to get the desired sizing here, we have to make several passes. So that's this tool here corresponds with this tool here. Next thing we're looking at is our right hand facing tool. So we've got our spindle here, and we've got this flat tool coming in here, and that's machining away this surface here to create a flat surface that's at right angles to this other section here. This next one that we've got is looking at a threading tool. So what we have here is this shaft being held in a chuck here at the end, and we'll talk about those in a little bit. And we have this sort of V shape, which is shaped to what we want our thread to be like. This is where we use that lead screw, so we can control the rate that this threading tool moves along, so we can create a nice constant thread in our material. Okay, so the one thing we don't have an image for here is our cutoff tool, but essentially this works by pushing this through the material far enough till it reaches the center point of our spindle, and then it obviously just cuts it off. So this is useful if we're working on long pieces of material where we need to cut it down into several different sections. And here just got an image of the production of a spherical sort of handle, and as you can see, this is made up of several shapes of revolution. To make this, especially by hand, would be quite difficult, and you generally use, say these days, it would be computer controlled to get the movement right to get these shapes, or you might be using a copy of that to mimic how to move along using the lathe there. So now we're just going to take a look at some more turning operations. So the first one here is tapered facing. So we have our tool here and it moves along with our carriage angled. We can now move along and create a gradually tapered surface, and our representation for that is that. So similar to just our normal turning operation, however we've just added an angle on the carriage. The next one is form turning, which is this here, where we can use a specific sort of die, something like this, which locks down onto our piece and gradually moves along, so it moves down in that direction, and this would be another way of creating a thread in this case. So we have form turning. The next one is boring. So we have our cutting tool located here, and we can set and we can gradually move that in and out to adjust the size of the diameter of this bored hole, and of course we can move it up and down in that direction to control the depth of the bored hole. Next one is tapered boring. So similar to boring and tapered turning, on our carriage we just angle the boring cutting tool and cut into our material like so. This one here, while not necessarily a cutting operation, we have two helical pieces here which, when pushed onto these surfaces here, create a knurling pattern. So these two pieces of metal here are obviously very hard steel, and we have a softer steel here, and it's able to then just mold and press that steel into a particular shape that holds, and that's called knurling, and that's sort of the look we get for it and our drawing representation. And that's something that can be used to add grips on handles and that sort of thing, which I'm sure you've seen before. This last one over here is drilling. So sort of opposite to our conventional drilling method where we have the drill bit spinning, we now have the workpiece turning. However, it produces the same effect, having this drill bit locked here, this turning and moving that drill bit further into our workpiece. Similar to drilling, we have internal thread forming. So tapping a thread, it's sometimes referred to. So we can lock our workpiece in over here, hold our tap over here, and then that gradually cuts into the material, producing a threaded internal surface. The last thing I want to do here about lathes is just about how we go about holding what we're working with in a lathe. So the first thing we're looking at is a 3-jaw self-centering chuck. This is very similar to what you find, say, on just a normal power drill. And so you got 3 little jaws. As you tighten it up, they move together. So on a round object, they will center on that, and it will end up locking in place. These are generally good for doing any sort of circular work where you need to rotate roughly about center. Probably won't get you precisely on center. And just another downside of this particular method is that once you've removed your work from your lathe, you generally won't be able to get it back on that exact same center again. And we'll have to look into one of the other holding methods if we need to keep taking our work in and out of the lathe. So yeah, generally used for round sections and hexagonal sections. Next one we've got is a 4-jaw independent chuck. So similar to 3-jaw, except we've got 4 jaws obviously. So this is generally used because we can control the position of each jaw for doing some off-center boring, that sort of thing, or eccentric boring, and can also be used for, say, milling on square sections or some other odd casted sections. Have here holding it between 2 centers, so we would drill small little points on the end of our section and it would be pinned between those sections. So this is a method we'd use if we had to keep taking a piece in and out of a lathe to check sizes and check our work as we go. At one end there's a clamp on one of the is held on one of the rotating sections to make the whole workpiece rotate. And just with those drill points that you have to put on the end of your work sections, using general drill bits, and they leave a 60-degree angle marking in our workpiece. Lastly, we have collets, and they're used for some standard cross sections. So how these work is we insert our workpiece into the section, and then as it gets clamped on there, it pulls it down and the top squeezes our section and it distributes the load evenly around the section, centering the piece we're working on and distributing the load evenly. These can generally have some good uses on particular things where maybe a 3-jaw chuck might not be appropriate. For instance, we might be dealing with quite a delicate soft material where inserting it into the 3-jaw chuck, the jaws might leave some marks on our material. So a collet can help avoid that. Similar case, if we're working with a threaded section, the chuck may damage that thread. However, you could use a collet and it wouldn't damage that thread. So that concludes everything for lathes. In the next video, we're going to take a short look at drilling.